Which expression is closest to 12.5? Let's look at each one of them individually. 4 times 3.1. The first thing I would do is a quick estimate in my head of 4 times 3, which of course is 12. So I can see right away that that is fairly close to 12. I don't know exactly what it is yet. I would have to multiply it out. So 4 times 3.1 is equal to 12.4. What about the second one? 2 times 7.7. Well, 2 times 7 is 14, so clearly that's not close at all. 9 times 1.2, same thing. I'm just going to multiply the 9 times the 1, and of course that's 9, which is also not close at all. And finally, 6 times 2.2. 6 times 2 is 12, so that's getting into the right range. But if I actually go through and do the 6 times 2.2, I end up with 13.2. So the one that is closest to 12.5 is A, 4 times 3.1. Which expression is equal to 8.11? We've got 4 possible equations here. Each of them are division questions. My first thought would be to again do some simple estimating in my head. So 24 divided by 3, that's 8. 32 divided by 4 is also 8. 41 divided by 5 is going to be 8 point something. 17 divided by 2 is going to be 8 point something as well. So I can see right away that they're all at least in the right range of numbers. The next thing I'm inclined to do is to look, since I've got a very simple number here, 0.111, I want to look at the last digits here and see if any of them are kind of aligning with that 1111. And so I can see obviously the 433, well, that doesn't really match up with 1111, but the rest of them do, the 444, 555, and 222. And obviously 4 times 111 gives me 444. Similarly, 5 times 111 gives me 0.55. And 2 times 0.11 is going to give me 0.222. So those 3 look like they're lining up, but I think I can probably rule that one out. Rather than doing the long division, I find it's easier to do multiplication than long division. So I'm just going to go ahead and take the 4 and multiply times 8.11. 4 times 8.111. 4 times 1 is 4. 4 times 1 is 4. 4 times 1 is 4. And 4 times 8 is 32. And I've got 3 decimal places. So I go 1, 2, 3. So I end up with 32.444. With luck, I found that B is exactly equal to 8.111. We're asked to estimate and show our thinking. So the first one, 4 times 3.2. The first thing I'm going to do is just 4 times 3, which is equal to 12. And it's going to be a little bit more than 12. Obviously, fairly easy numbers to work. 4 times 3.2 is actually 12.8. But 12 is certainly a reasonable estimate. Looking at the next one of 6 times 12.8, my thinking would be to look at 6 times 12, which I know is 72. And since I've got a 0.8 times 6, I know that that's going to add a little bit more to my 72. 6 times 8 tenths is 48 tenths, so that's going to add another 4 to this. So my exact number of 6 times 12.8 is going to be 72 plus 4.8, which is 76.8. Now 9.42, I'll move that one down here to do. So again, start off with the 9 times 4, which is equal to 36. It's a reasonable ballpark. I know that if I have 9 times 2 tenths, that's going to give me 1.8 more. So when I do the actual calculation, of 9 times 4.2. I'm going to have 36 plus 1.8, which of course is 37.8. 11 times 4.2, 11 times 4 is 44. When I've got the 0.2 times there, so 11 now times 0.2, that's 22 tenths, or 2.2. So 11 times 4.2 is equal to 44 plus 2.2, which is 46.2. And this final one, I'm going to pull all the way over here just to make use of the space that's available. 33.2 divided by 4. In this case now I'm going to be looking at my 4 times tables. What 4 times will get me closest to this number? Well, 4 times 8 is 32, and that's pretty close. I know that my number is going to be a little bit more than that because this number is slightly bigger. The 33.2 is a little bit bigger than 32, so that means my 8, it'll be a little bit bigger than 8, but not by too much. Now we're asked to calculate these precisely, so I've got 8.648 divided by 2. Using the traditional method, number of 2's in 8, 4 times, 2 times 4 is 8, 0 remainder, bring down the 6, 3 times 2 is 6, 0 remainder again, bring down the 4, 2 times 2 is 4, 0 remainder again, bring down the 8, and 4 times 2 is 8, so remainder of 0 again. We've lined up our decimal place, so part A, the answer is 4.324. You could have also done that same question by simply dividing each of those pieces in half. So half of 8 is 4, half of 6 is 3, half of 4 is 2, and half of 8, of course, is 4. So it gets us the same number just by going through and doing them one piece at a time. 15.4 divided by 4. In my estimate, in my head, I'm thinking, okay, well, 15.4, it's a little bit less than 16. Of course, 4 times 4 is 16, so I know I'm going to get a number a little bit less than 4 in getting my final answer. So the number of 4's in 15, 3 4's are 12. 15 minus 12 is 3. Bring down the 4. 8 4's are 32. 2 remainder. Now I've got another 0. I can always just keep adding as many zeros as I need, so I can bring down the 0. Number of 4's in 20 are 5. 5 4's are 20. Subtracting 20 gets a remainder of 0. So 15.4 divided by 4 is 3.85 with a remainder of 0. Choose one of these values for the perimeter of a rectangle. Use the first one. List 2 possible length and width combinations that would lead to your perimeter. Show your thinking. Well, if I start with 3.4, I know that my 2 lengths have to be less than that because I also have to have some widths thrown in. So that means 2 times some number is going to be less than 3.4. So if I say my length is going to be 1.5, then 2 times my length will be equal to 3, because of course that's equal to 2 times 1.5. So if I've used up 3 of the total length of 3.4 in my perimeter, then 3.4 minus my 3 leaves me 0.4, and that's what I need to then use for my 2 widths. So if width plus width is equal to 0.4, then I can assume that one width is just going to be equal to half of that, which would be 0.2. So I end up with a length of 1.5 and the width of my rectangle as 0.2.